Welcome, I'm Kevin King. In this, the third of our series of 6 in-row training videos, I'll show you the user screens for our within-row guidance system. This presentation builds on information from our inter-row guidance videos, so if you've not already done so, you might benefit from watching the equivalent inter-row video presentation first. As you can see, the home screen is identical, but with the addition of an in-row button with 9 distinct plants on the logo. We install both inter-row and in-row applications, allowing the implement to also work as an inter-row cultivator once the within-row cultivators are removed from the row. The in-row user interface is a progression from the familiar inter-row working screen, so many of the features are common. One major difference is a fore-aft fine offset adjustment, as shown here. This is in addition to the lateral fine offset available on the inter-row version. Fore and aft offset adjustment advances or retards in-row rotors, nozzles or actuators. The green dot indicates the offset applied in both directions. To adjust offset, first select the direction to be applied with the Direction Select button. The direction will change with each button press. Repeat button presses until the arrow in the button below reflects the direction of adjustment you want to make. Each button press equates to 1 cm both laterally and in the fore and aft direction. Each camera has its own fore and aft offset relating to all devices associated with the rows being tracked by that camera. So to change the fore and aft offset, first select the relevant camera and adjust the fine offset. Like the inter-row working screen, the area at the bottom left is reserved for graphical warning messages. Additional in-row system warning messages include tracking errors in the fore and aft direction, indicated by a warning triangle with a vertical arrow. If the tracking error relates to a single device, its row number is displayed with the triangle. A 12-volt battery symbol indicates that the 12-volt power supply to the implement is low. A 42-volt battery symbol indicates that the 42-volt electric rotor power supply voltage is low or turned off. If a hydraulic condition monitoring board is fitted, there are also a series of warnings relating to the supply pressure being too low, the tank line pressure being too high, overheating oil, or block filters. A warning triangle with the letters CAN indicates a CAN communication failure. View the error log and hardware map to further diagnose individual CAN bus device status. Electric rotor overload symbol indicates that one or more of the rotors have been shut down to avoid overload. A system shutdown and restart may be required to reset rotors after an overload. An electric rotor and a thermometer symbol indicates that the rotor is overheating. A leaking pipe symbol is displayed if spray pressure monitoring detects a leak in the spray system. Touching on the spanner button at the top right takes you to the in-row setup screen. Again, this screen should look familiar. It is the same as the inter-row setup page with a few extra parameters. For example, on the third line down, we now have plant spacing within the row, which can be adjusted in 2.5 cm increments to suit the average plant spacing in the field. It is best to set the plant spacing at or just below the measured average. A good way to work out the average plant spacing is to measure the total distance over 11 plants or 10 plant spacings in the field and divide this value by 10. Clearance adjustment, an optional setting, allows electric rotor entry and departure points around the plant to be altered to increase or decrease uncultivated buffer area around each plant. Spray mode only applies to nozzle applications and allows for nozzles to operate by avoiding crop or spraying crop. The plant zone parameter only applies to the control of nozzles or reciprocating in-row blades. It is the linear distance around a plant between which the valve state changes. Increasing plant zone increases the buffer zone around each plant. Camera setup parameters are the same as the inter-row systems, but in this case the horizontal distance of the camera ahead of the cultivators refers specifically to the in-row devices, rotors, reciprocating blades or nozzles, and needs to be measured with some precision. We will talk more on this in our setup video. Where rotors are fitted, the rotor disc size used by the computer to calculate disc path is displayed here. It is important that the disc fitted to the machine matches this value. This screen offers the same information, diagnostic tests, options and settings as the Intero, but with some additions. Alongside the area and runtime, both the number of crop plants treated and the number of crop plants located is logged. If we select Job Stats, we get a summary of the statistics gathered since the last time the job was reset. These include area treated, elapsed time since the last reset, crop plants detected by the system, crop plants thought to be remaining after treatment. This may be slightly lower than those detected if some of those plants were too closely spaced and were deliberately thinned to achieve a better plant stand. Plant population, calculated from the number of plants divided by the treated area. Average plant spacing and variability in that spacing, expressed as a standard deviation. Average plant size expressed as a linear distance across the foliage width and a size variability expressed as a standard deviation. Along with the steering test available on Intero machines, there are a number of additional tests for connected CAN devices. The Test Rotors option will be displayed if rotors are fitted. It runs each rotor up from stationary to maximum speed and back down again, displaying a plot of demanded speed against actual speed. They should have a one-to-one relationship, outputting a straight diagonal line. Rotors can be all tested in mapped order, or individual rotors can be selected for testing. While these tests are being performed, sensor signal quality is also monitored to ensure that sensors are operating correctly. If a test passes, an OK message should be returned. If hydraulic rotors are fitted, there is an additional flow test available, not shown here, to check for an adequate oil supply and the option to calibrate the rotors. Details of these functions can be found in the manual. If nozzle boards are fitted, a nozzle test will be offered that operates each nozzle in turn, providing the opportunity to do a visual inspection. If a spray condition monitoring board is also present, then 2 additional tests will be offered. They are a leakage test that looks for pressure drops, and a blockage test that checks that the pressure does in fact drop when the nozzle is triggered. If nozzles are fitted, the flush nozzles option will also be displayed. This activates alternate channels for 1 second at 1 second intervals. This can be used to flush chemical out of spray lines. The Test Cultivators options will be displayed if reciprocating blades are fitted. Test Cultivators operates individual cultivators through open and retract cycles in turn. Test All Cultivators runs alternate output channels at 1 second intervals to simulate actuators being in use. This test can be used to check if the tractor's hydraulic supply has sufficient flow. The bottom 5 lines of the Advanced Settings and Diagnostics page of audible warnings, leave manual on moving, fine offset flip, error log and microcontroller version are the same as for the Intero software. We hope that you have found this presentation useful. Remember that it's the third of a series of 6 videos that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material. If you have any questions, please get in touch. Thanks for watching.